How do we know we have a great design? We can think about our product's affordability, simplicity, and value. But to whose measurement? Let's talk more about this after the brief introduction. Hello and welcome to Quality During Design, the place to use quality thinking to create products others love for less. Each week we talk about ways to use quality during design engineering and product development. My name is DIANNA. I'm a senior level quality professional and engineer with over 20 years of experience in manufacturing and design. Listen in and then join us. Visit qualityduringdesign.com. I have been getting catalogs and links to articles about holiday gadgets, and we are back in full swing. I love looking at gadgets, the products that do something old in a new way. And I also enjoy looking through the toy guides. Those interactive robots are not going away, and they're a lot of fun. The other place I love to go is the made-for-TV in the mall, just looking at the inventive gadgets and things that people created and designed and engineered in order to solve a problem. Some designs are great. They are engineered to be affordable, simple, and valuable. And those are the ones that interest me the most because I know it takes real intention and effort during engineering to do this. We don't end up with great gadgets by chance. Other designs are not great. They could be affordable, but not simple. They may be complicated or require extra steps to get started. Toys are notorious for complicated packaging. When my kids were younger, they would get a fantastic new toy and it would take an adult 20 to 30 minutes to get it out of the packaging. Other designs are not great because maybe they're affordable and simple, but not valuable. And the first category that comes to mind for that is just that they're made cheaply. Maybe they work once and then they break when they're not supposed to break after one use. I had picked up a little drone. And reading the instructions, it said you can't fly it outside. It has to stay inside. So we flew it inside, and then it quickly got a hair twisted around one of the rotors, and then it burned out. I didn't consider that very valuable. Other products may not be engineered well or to proper use conditions because they don't work as promised. Or worst yet, or the worst category of them all, is that they are purposefully bad. They don't work as they promised. And those are the ends of our balance, the extremes. And there's lots of gray area in between. I'll retell a story from my dad. This is way back when plastic injection molding was just getting started decades ago. He is a designer and inventor, but more than that, he also designed tools. He's a journeyman tool and die maker. He made the tools, and he eventually grew his business to have injection molding equipment too. Before he had his own place to make tools, he was also a designer. And he was approached by a client who wanted a yard spinner, a yard ornament. It's something that has a stake that you stick in the ground and it spins in the wind. And he designed it to last. He showed it to his client, and his clients were happy with how it looked, but then they pushed it back to him and asked him to make it so it would break in a couple of years, so people would have to buy a new one. In this case, we had a product that's engineered to be affordable, simple, and valuable, and people wanted him to engineer it to be less valuable over its lifetime. This thinking still happens, but I would like to think it's a bit less. I also think this bothered him because he'd tell me about it a few times, decades after the fact. In the view of his clients, he over-engineered it. Even after he changed it, it was the same cost to make. It stayed simple, the design didn't change as much, but to his clients it was less valuable because they wouldn't get to sell as many over the long term as they'd like. Now, when I talk about value from a quality professional viewpoint, I'm talking about the end users. I picture a grandma that picked up a pretty yard spinner for her yard. She could afford it. It was simple, push the stake into the ground. Was it valuable to her? Maybe it was enough value considering the cost. Today, engineers are expected to consider more end users. Can the yard spinner be recycled? What's the cost and difficulty of that? What is the cost to our environment of the manufacturing, recycling, and disposal? It may no longer be affordable in those measures. In the case of the yard spinner, let's give the clients the benefit of the doubt. Perhaps they were creating a financing plan to be able to afford what was needed for the group to start making yard spinners in the first place, in which many people were employed. I don't know the answer. It was before I was born. I can tell you that years later, while I was young, my dad invented, produced, and sold his own yard spinner that is virtually indestructible, and, in my opinion, much prettier. He's looking to sell them again if you're in the market for a yard spinner. He engineered them for grandmas and everyone to be affordable, simple, and valuable. If some great designs like gadgets are meant to be affordable, simple, and valuable, how do we know we've got it? How do we know we have a well-engineered design? We must do the upfront work and do it well. Concept development and design inputs. Because we can't do it by ourselves. We need a team of people to help. It takes many people to make a product a reality. We have our customers or customer-facing coworkers who can help define criteria from our customers. What would Grandma have wanted most with her yard spinner? What do they think is affordable, simple, and valuable? How are we going to set up our engineering design inputs to match with that? Customers are number one. Without them, why are we designing anything? Supplier management and manufacturing are needed to help cost out parts, components, and figure out manufacturing. And there's usually trade-offs involved. We're limited with the supplier list because of their capability. Or maybe their stance on global initiatives, for example. We may be limited with our choice of material in the first place. We can't package Grandma's yard spinner in foam because she lives in California, and we can no longer ship foam to California. Or we can no longer source the resin and colorant that we wanted. Quality engineering can help with the quality across the product development and delivery process and within engineering design. And reliability engineering can help us design with quality of the product over time. We may also look to our company to help us define our customers and what they want. We're working for a company, and it should have a quality statement. Sometimes they're worded more for stakeholders than employees, but there should be a sense or a statement or a mission or a vision about what is important to that company's customers. What defines quality for them when using or buying products from our company? Is it style, longevity in use, dependability? It depends on what we're designing for whom, and that may be defined by the company that we work for. Our customers could also be baked in as part of the regulations in our specific industry. Engineering with a team takes effort and intent, just like engineering a great design. Most of the effort with a team means being proactive. It involves communication and uses our understanding of how other people affect the design choices we make. We can't rely on our team to feed us information or just hand us a tidy memo of what they think is important. It's not enough for great designs. We need to proactively reach out to get that information for ourselves and for our team. Because we want to engineer with intent, we need access to that information close to real time as design choices are made. Our goal for touch points and meetings is to learn, discuss ideas, and decide on actions to move the project forward. And it can be iterative communication. It doesn't have to be a full day of off-site meetings. In many cases, iterative would be better. A way for engineers to iteratively communicate and get the information they need is through quality and reliability methods and tools, which is what I coach and have developed courses to help teach and what I podcast about. So what's today's insight to action? Affordability, simplicity, and value are measured by our customers, and design engineers have many customers. It takes a team to make a product happen, and engineers can make concept development and design inputs a team activity. Using quality methods may help with communication, gathering information, and being able to make decisions about the concept and design in early phases of development. If you want to see if you're getting a great start with design with your team, sign up for our free checklist. The 12 things you should have before a design concept makes it to the engineering drawing board. You'll gain access to a portal where you can explore more about what's on that list and why with short modules. It's free. Click the link on the homepage at qualityduringdesign.com. If you like this topic or the content in this episode, there's much more on our website, including information about how to join our signature coaching program, the Quality During Design Journey. Consistency is important, so subscribe to the weekly newsletter. This has been a production of DIANNA Enterprises. Thanks for listening.